What we've got over here is a Fluke 754, and we are connecting to a Rosemount 644 transmitter. We're providing loop power through the 4020 milliamp jacks, and also we can talk HART through these milliamp loop here. And then we're also sourcing or simulating a thermocouple signal to the transmitter, so we can do a full calibration with this setup here. So if you notice, we've got our source and measure set up. If I press the HART button, we're going to go ahead and look for a HART device out there, and it finds that 644 transmitter. It's called TT1, and you can see the lower and upper range values on here. What we're going to do next is we're going to actually do a calibration. So I'm going to press the HART button again. We're going to measure milliamp source thermocouple type K. From this screen now, what we've got is we have already downloaded some tasks from ProCal. So if I go to more choices and hit tasks, you'll see I've got a few tasks that I've downloaded, and you'll notice down here TT1, and that's this guy here. So I can bring it up, and you'll notice you can program into the from the software. You can get the information about the device so the technician knows where things are located. Also, you can send a message to the technician from ProCal. In this case, I just said verify the box is open before testing, and then we'll continue. And you'll notice, so all the information that I need to know about my calibration has been downloaded from ProCal to the calibrator. So we know that our measure is going to be 4020 milliamps. The tolerance has been set in this case to 0.5. This is all this stuff selectable by the user or the admin. We're setting up a 10-second delay because we're going to do an automatic calibration. And then on the source to 0 to 300 degrees C. And the test strategy is how many test points that are required for the test. And again, this is determined by when you're setting up the configuration in ProCal. Okay. Now, here's a fun part. So with this calibrator, we can automatically run tests without having to do any manual stuff. So this is going to automatically source the thermocouple signal and measure the 4020 milliamp and go through each test point with that 10-second delay. So I'll hit Autotest. And so we're going to test this guy out and see what it looks like. And again, this is a 5-point test, so it's going to check at 4 milliamps at the 25, 50, 75, 100%. And you see we're going to 75 now, then we'll go to the next step up. And each one of these, the calibrator is actually capturing the milliamp value for each of these test points. So none of this stuff has to be written down. It's all automatic. It's highly accurate, and it makes life a lot easier. And I can be drinking a cup of coffee while I'm doing the calibration, so it makes it kind of nice. So once all the information has been captured in this calibration, and this is called the as found. So this is when you first bring your calibrator to the device and you connect up and take your readings. This is the as found. And you'll notice, well, this transmitter is not in too good a shape. We got a lot of inverse video, which means it's out of spec. Remember, we had it set for a 0.5% accuracy. We're over that right now. So what we're going to do is continue. And we've captured all this information in the calibrator. Now we've got the tag ID name. We're going to capture that, the serial number, and then the ID of the technician's name. Whoever did the test, it will be included. We'll continue. Now at this point, so we know we're out of spec and we need to make some adjustments. So we can go in and hit the adjust button, and you notice we can adjust the 4020 output trim, and we can also adjust the input sensor trim. So let's start with the output. So we'll hit enter. Make sure we're connected to the device. Okay. Now if you'll notice the PVAO, this is a process variable analog output of the transmitter. The transmitter thinks it's putting out 4 million, but the SEM 54 says, well, no, I'm reading 4.2. And of course, the calibrator is going to be at least 4 times as accurate as the device it's testing. So this is the number that we're going to go with. So what we need to do next is we need to tell the transmitter that it's out of spec and have it pretty much repair itself. So we're going to fetch that 4.2 milliamp value, and then we're going to send it to the transmitter and tell it to fix itself. And it does. You'll notice now it's putting out 4 milliamps. We'll continue to the 20 and do the same thing. You'll notice it thinks it's putting out 20, but it's actually putting out 20.2. So we'll fetch that value, send it so that the transmitter can correct itself, and we're done. Next, we can do the sensor trim, and we'll enter here. If we have a dry well in the setup, we could use that, but we don't. We're just using the output of the SEM 54, so we'll go ahead and do that. We're going to do both the upper and lower values. Okay, next source. Okay, lower range value is 0, so we're going to set that in trim. Device malfunction. I'm wondering if give me a second. What's the drywall? Okay, let's try it again here. Sometimes these transmitters don't work the way we want them to. We'll hit lower range value. And hit trim. And so it's going to set that lower range value to 0 degrees C. Once complete, then we're going to continue and go to the upper range value, which, if you remember, is 300 degrees C. So we're going to set that and trim. And once that is done, we've completed our sensor trim. We've hit the low end, the high end. Okay, and we're done. So now we're back to the main screen. So we've done our as found, and we've recorded the readings. We've made our adjustments, and now we're going to perform the as left. So this is as you finish up your calibration. You've done your initial test, you made your adjustments, do the as left. We've got our same configuration information that was downloaded from the software from ProCal here. And then we'll do the Autotest. So again, it's going to repeat the calibration test at the 5 different strategy points. Go from 0 to 75 to 150 and so forth. And it's now capturing. If you notice, you're starting to see some numbers that look a little bit better than before. And we're not going to see the inverse video anymore if we've made the adjustments, which it looks like we're doing a pretty good job here. So again, once it's completed with the as left test, this information will be captured in the calibrator. And all this is important data, because this is what gets sent back up to the ProCal software and gets populated into the database. So as you notice now, we've completed our test, and wow, look at the error percentage now. We are pretty much right on the money. Okay, so we're well within the spec. We're in good shape here. We'll continue. Again, it's going to record that same data. The tag ID number, the SIL number, who did the test, and that's it. So we'll continue, and then it says, okay, the final message that can be put in. If there's a message for the tech, let's say to turn lights off or close the box, whatever, that's done. So now that information has been captured into the calibrator, and if I review memory, you'll see here's that calibration result. Now remember the report that Mike showed you. If we look at this, we have our as found and as left results. I'll enter in on the as found, and you'll notice here's all that configuration information that you see in that calibration report. This gets saved, and then if we go to the next page, you'll see that as found data. So here's all that stuff that was out of spec, and this gets documented, saved to the software, so it can be reviewed later. You know, wow, this thing was out of spec when you first went out and looked at it. When you're completed, then you go down to the as left, and again, this gets captured as well. You'll see here's the configuration information. Go to the next page, and there are your as left results. So this calibration has been completed. This transmitter is back in service because it's looking good.